Okay, we've talked about squares and square roots. Today we're going to talk about cubes and cube roots. So, cubing a number, what does that mean? Well, do you remember what squaring a number meant? Squaring a number meant multiplying it by itself 2 times. So for example, 4 squared, what that means is 4 times 4, and then what it equals, well 4 times 4 is 16. And remember, the reason it was called squared is because if you made a square and the sides of it were 4 and 4, the way you could get the area of this, or the way you could figure out how many little squares are inside of this thing, sorry it's hard to draw, is you would go 4 times 4 and there's 16 inside of here. Well, now we're talking about cubing a number, so we're no longer talking about squares, 2-dimensional shapes, we're talking about 3-dimensional shapes. So cubing a number is multiplying a number by itself 3 times. So if you were doing 4 cubed this time, that means 4 times 4 times 4 again. See, we're multiplying by itself 3 times. 4 times 4 is 16, and 16 times 4 is 64. In terms of the picture, what that means is, if you were finding the volume of this cube, if you had 4 little squares going across here, they'd actually be cubes, not squares, and it went back 4, 2, 3, 4, and it also went up 4, 3, 4, and you want to know how many cubes, how many building blocks made up this whole big block here, it would be 64 building blocks. I'm not sure if that's so clear, but anyway, this is cubing a number, multiplying it by itself 3 times. We can also say it was raised to the 3rd power, or raised to the power of 3, right? Again, remember that this little number here is the power. Okay, so we're raising 4 to the power of 3. We're raising 4 to the 3rd power. Alright, so let's try a few of these. The first one we have here is 2 cubed. What does it mean, first of all? It means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. That's your answer. 5 cubed. What does it mean? It means 5 times 5 times 5. You don't need to write this part down. What you need to write down is the answer. 5 times 5 is 25, and 25 times 5 is 125. You can see the numbers get big very quickly when you're cubing a number. 10 cubed. Lots of times people put 30 here for some reason. Nope, it doesn't mean 10 times 3. It means 10 times itself 3 times. 10 times 10 times 10. Well, 10 times 10 is 100, and 100 times 10 is 1,000. As I said, they get big real fast. Okay, now we're going to do the inverse, right? The opposite. We're going to do the cube root. So before we looked at square roots, remember we had stuff like the square root of 9. And what did that equal? It equaled 3. Do you remember why? Because we were looking for a number that multiplies by itself to give the radicand, that inside number there. And what multiplies by itself to give 9? It's 3. Well, now with cube root, you're not looking for a number that multiplies by itself 2 times. You're looking for a number that multiplies by itself 3 times. What number was multiplied by itself 3 times to get whatever number's inside the radical sign? So you're finding the number that has been cubed. Now, the way we designate that, how we show it, how we denote it, we use a radical sign again. So we use this sign right here, just like we did before, but we put a little 3 right here. Okay? Now, remember back here, we didn't put a number up here, but you actually could have. This is another case where we have one of those invisible numbers. Any ideas what the invisible number would be here? 2. Why? Why is it a 2? Because you're looking for a number that multiplies by itself 2 times. 1, 2. So in this case, because there's a 3 here, we're looking for a number that multiplies by itself 3 times. So if we were doing this, the cube root of 27, we're looking for a number that multiplies by itself 3 times, and we get 27. It has to be the same number in here. Let's try 3. 3 times 3 is 9. 9 times 3 is 27. We got it. The cube root of 27 is 3. And why is that the answer? Because 3 times 3 times 3 equals 27. Now, these numbers here, 27 and 1 and 64, these are perfect cubes. Remember your perfect squares? You could take the square root of a perfect square and not get a decimal. Well, perfect cubes are the same. You can take the cube root of them and not get a decimal. So let's look at 1, the cube root of 1. So what's a number that multiplies by itself 3 times, look at that's called the index there. Maybe I'll just write that right here. This 3 right here is called the index. I-N-D-E-X, index. So in cube roots, the index is 3, and in square roots, as we just said, the index is this invisible 2 that you can put if you want, but you don't need to put it for square roots. Okay, so sorry, back to this question. We're looking for a number that multiplies by itself 3 times, and you end up getting the answer 1. Well, I hope it's pretty obvious that that would be 1. 1 times 1 is 1, and 1 times 1 is 1. Yep, you can multiply 1 by itself as many times as you want, and you still get 1. Okay, in this one, cube root of 64. We're looking for a number that multiplies by itself 3 times and gives you 64. Well, 5, remember, got us to 125, so it has to be less than that. How about 4? 4 times 4 is 16, 16 times 4 is 64. Yes, in fact, I think we talked about this somewhere at the top of the page, so the answer is 4. Fractions. Well, fractions we did before with square roots. It's exactly the same for cube roots. If you have a fraction like a over b, I know those are letters, but those can represent any number, and you're cubing it, remember that was equal to? You could cube the top number and also cube the bottom number, right? And the other way, if we are cube rooting a fraction, so I'll put a over b for my fraction, same sort of thing. You could cube root just the numerator and cube root just the denominator. Okay, so those are actually the rules. Same rules for square root. I'm just writing them in mathematical symbols instead of in words. Alright, so the first one, 2 over 3 cubed. So again, there's 2 ways you could do this. You could actually just say, well, 2 over 3 cubed means 2 over 3 multiplied by itself 3 times, and then get that answer. That's easy enough. Multiply across the top, multiply across the bottom, you got your answer. Or the other way you could do it, based on these rules we just learned, you could do 2 cubed over 3 cubed. 2 cubed means 2 times 2 times 2, just like here, 2 times 2 times 2, which is 8. And 3 cubed means 3 times 3 times 3, which is 27. 3 times 3 is 9, 9 times 3 is 27. So that's your answer. Okay, cube root of this. So we could do cube root of 2 and also cube root of 16, but I see some problems here. Do you know what the problems are? We're looking for a number that multiplies by itself 3 times and gives 2. There's no such number. Uh-oh. Doesn't work for 16 either. If it was square root, it would work. This is cube root. Are we stuck? No. Remember my advice from before with square roots. If you're dealing with fractions, make sure you always put them in lowest terms. So, uh-oh, I forgot my equal sign. We should have cube root of 2 over 16. Divide them both by 2. 2 divided by 2 is 1, and 16 divided by 2 is 8. Okay, now you can do this. Now you can take the cube root of the 1, the numerator, and cube root of the 8 in the denominator. Whoops, got to put my little index. There's the little index. There's the little index, the 3. Okay, cube root of 1. I think we've done that before up there. Number that multiplies by itself 3 times to get 1 is 1. Cube root of 8. A number that multiplies by itself 3 times and gives you 8 must be pretty small. It is. It's 2. 2 times 2 is 4. 4 times 2 is 8. So 1/2 is our final answer. Okay, one more fraction question. The cube root of 15 and 5/8. Uh-oh, what are we going to do this time? Well, you don't want to have your fractions in mixed form. You want to switch it into improper. So 15 times 8, ooh, that's not easy. That's 120. Plus 5 is 125. So you get 125 over 8. Check to make sure it's in lowest terms, and it is. And now, take the cube root of the top and the cube root of the bottom. So, cube root of bottom, we just did that. Cube root of 8 is 2, so we can write that down. Cube root of 125, a number that multiplies by itself 3 times to get 125. I think I've said it a few times in this video. 5. 5 times 5 is 25, and 25 times 5 is 125. So your answer is 125 over 2. You're welcome to change it to 62.5 if you want, but you don't have to. Okay, next, inverse operations. We talked about this before. Remember inverse operations? They undo each other. So they reverse the effect of one another. So we talked about add, subtract, undo each other. Multiply, divide, undo each other. We talked about square and square root, undo each other. And now we've got, not surprisingly, cube and cube root. So I'll do the first two long form, and I hope it's kind of clicks in your brain again about how fast these should be. This question says the cube root of 3 cubed, and the 3 cubed is all under the radical, so we should do that first. So cube root of, what's 3 cubed? Well, that means 3 times 3 times 3, and 3 times 3 is 9, 9 times 3 is 27. So now what we've got is the cube root of 27. So we're looking for a number that multiplies by itself 3 times, and we get 27. That would be 3. Wait a minute, remember this? If you started with a 3 and you cube it and cube root it, you end up back at 3 again. You didn't even have to do all this work that I did here. This was completely unnecessary. Okay, I'll do one more like that, and then again, we should be able to do any other question like this in mere seconds. In this one, in brackets, it says cube root of 8, so we have to do that first. What number multiplies by itself 3 times to get 8? Oh, we've done this one before. It's 2. 2 times 2 is 4, 4 times 2 is 8. So in the brackets, we have 2, and then we're cubing it. Well, that means 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. We're right back to where we started again. We started with 8, we took the cube root and we cubed it, we got back to 8. So hopefully you remember how to do this now, because you can do it so fast. Cube root of 52, I have no idea what that is, and then I'm going to cube it. Well, I don't know what it equals when I take the cube root, but I know when I cube it, it's going to undo it, so I'm going to be right back at 52 again. Okay, estimate a non-perfect cube root. So maybe before we talk about non-perfect cube roots, we should make a list of perfect cube roots. Remember we had a list of perfect squares, numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, right? Numbers like that. Maybe we should make a list of perfect cubes too. Hey, what do you know? I've already done it right here. These are a list of perfect cubes. How come? Because 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2, 8. 3 times 3 times 3, 27. 4 times 4 times 4, 5 times 5 times 5, 6 times 6, 6, 7, 8, 9, all the way up to 10 times 10 times 10. Of course, it keeps going, but as you can see, they're getting big really fast. I usually say if you can remember up to this 216 number, you're probably pretty good. So if we're taking a cube root of any of these numbers, it's actually really easy. The cube root of 27, 3. The cube root of 64, 4. The cube root of 1000, 10. But what if we're taking the cube root of a number that's not on this list? What if we're doing the cube root of 24, for example? Well, it's not on our list here, so it's a non-perfect cube, so we're going to have to estimate. So just like before, there's two ways to estimate. One way to estimate is to use a calculator. But remember, it's only going to be an estimate, because what kind of answer will you get? You'll get a decimal. So for example, if I did the cube root of 24, I'm sorry, I'm using a different calculator this time. So it says cube root of x, and x is the radicand. Remember that radicand's the number inside. So if I just put 24 in here, it's going to take the cube root of 24. And let's see what we get. I don't think we get as many decimals as last time. So we get 2.88449914. Hey, pretty cool number. Does it actually stop there? No, it keeps going. How long does it go for? Forever. When does it repeat? Never. Okay, it's a decimal that goes on and on and on forever, never repeats, never stops. Okay, I'm cheating. The cube root of 24 equals 2.88449914, ... keeps going, never stops, never repeats. Alright, but you're not going to be able to use calculators in this chapter, so how are you going to do it? Same as with square roots, you're going to use benchmarks, and these are your benchmarks this time. So remember how to do this? The first question you ask yourself is, where did 24 fall between on this list of numbers here? Of course we have a different list, but it just works exactly the same as before. So 24 fell right around here, right? It's between cube root of 8, which we can figure out, and cube root of 27, which we can figure out. What's the cube root of 8? Well, I've talked about that a few times. It's 2. What's the cube root of 27? We've talked about that a bunch of times. It's 3, because 3 times 3 times 3 is 27. So what's that mean for our answer? Our answer must start with 2. 2 point something. Now, we ask ourselves, is 24 closer to 8 or 27? It's quite a bit closer to 27, isn't it? I put 24 way up here. So I don't know, it's probably, well, we just did it, but I would probably guess it's about 2.8, maybe 2.9. I'll tell you what, I'm going to go with 2.8, and then let's take a look again at what our answer was. 2.88. So see, I actually wasn't correct. It actually was 2.9. But I would give you the marks for sure for 2.8, 2.9, maybe even for 2.7. but it should be no less than that. Okay, the rest are just like that. Cube root of 129. Well, it falls between 125 and 216. So cube root of 125, cube root of 216. I think we've talked about 125 quite a few times. It's 5. 5 times 5 is 25, and 25 times 5 is 125. 216 we haven't done, so if you get confused and you have this list, remember you can just count over. This is 0, and that goes 1, 2, 3, 4, 5, 6. 6 times 6 times 6 must be 216, and it is. And also, it has to be one more than the 5, so that makes sense too. Okay, so our answer is going to be 5 point something. Is 129 closer to 125 or 216? Way closer to 129. I'm thinking the answer is either going to be 5.0, and it just doesn't round up, or 5.1. I'll go with 5.1. I'd probably accept 5.0, 5.1, or 5.2. Do you want to know what the actual answer is? Of course you do. So here we go. We just put 129 in here. Hit calculate. And we get 5.05, which does round up to 5.1. Okay, everyone, I'm going to stop there. This video is getting too long, so I might talk about these last examples in class. So again, I'll have this list of cube roots in the classroom for you to help you out. And if you need more help, just ask. Take care.